Everybody, it's Rev from Into Gaming. Today, we're going to be taking a look at hit detection, what it is and how it happens and what does it and so forth. We're also going to be taking a look at shooting systems, like the entire platform or model, so we can so to speak. So like client fakie server auth or client server hybrid, etc., etc. In general, it's projectile based on the two systems that I just mentioned, and yeah, we're gonna take a look at that and dive right into this. So, my particular system that I've been working on for the last few years, or using in the last few years, is a AAA model called Client Fakie Server Auth. It's a minimal data system, where we're not replicating a lot of data over the network, so I'm not sending you a whole bunch of packets about a single shot that's fired down. It's a fire and forget kind of thing, and it's broke up into the three proxies. You got the autonomous, which is you. We have the server, and then we have simulated proxies. Um, if you watch any of my other videos, you'll know what simulated proxies are. Um, but other than that, I'm gonna give you a quick brief breakdown. I'm the blue guy. On the left hand side of the screen, I'm looking at the green dude. The green dude sees me. He's on the right hand side. He's client 2. If you look at the top of those two windows, you have client 1 and client 2. I'm playing client 1. Client 2 is Joe Bob, and he's seeing me do the things, and he sees I got a gun, and so forth and whatnot. And when I shoot, he gets a message from the server to shoot, and he does his thing. So when I fire my weapon, I'm actually uh, using a projectile, pushing it down range, simulating it down range, and when my projectile on my game, on in my simulation, the game world, it hits something, it automatically determines what effects to apply. So if I hit the ground here, if I shoot the ground, I get a squib that does dirt, and I have a dirt-based decal. If I hit something that's got concrete, I get a concrete squib and its decal. If I hit a player, I don't know if you can see it, I get a blood. I get blood splatter coming off, and they get a decal. If I can scroll, get up here, and there's a little bitty decal. They fade out after time. But this is all happening in my simulation. The servers, when it gets the information that I shot, it fires its own projectile downrange, and it keeps it in its simulation. It doesn't tell you anything about that shot, where it's at, or anything. It tells, it sends a packet to everybody telling their copies of me. See the guy on the right hand side jumping up and down. It sends a packet to them to tell them to fire a shot. This is where the projectile starts at, and it should generally start at the muzzle, but that's not a guarantee based off of movement and so forth. Um, and it you're so like let's just say I fire a shot, you get the packet on your client. Your client is actually simulating where that shot's going to go in your simulation. The server just gives you the start point where it starts and the velocity on it to push it downrange. And then your client takes over and simulates your own local. So when the shot hits in your simulation, so on the bottom right of that screen there, it's hitting the ground. Let's see if I can get one right on the corner there. See where we're hitting in the same spot. So the accuracy of this data transfer is pretty on point. It might be off with a floating point precision just a bit, but it's pretty daggone accurate. We're hitting the same spot. So each proxy, the autonomous, the guy that actually fired the shot, the server, and the sims are running their own simulation of the shot. Each has their own dedicated projectiles for the shots and so forth. So, getting into that. The projectile class, this is one for the client. It has a collision that does the hit detection, and it has a mesh, and then it has a movement component that actually moves the projectile. And let me just pop in, see if I can pull. We got the server, and we'll get the sims because they're all a little bit different. So we have the client side, we have that collision and the mesh and the movement. Servers have collision and movement. They don't need the mesh. The mesh on the client side is for our visual effects. So like in Battlefield 6, you have that tracer. That's what this would be. I just got mine scaled down to the actual projectile speed for any given reason. I don't need to see it in my my debug setup. And the projectiles themselves are the sphere radius on that collision, and we got the collision highlighted, is 0.5 centimeters. So it's a half a centimeter radius. So 1 centimeter in diameter. It's very small, a very small projectile. Now I just happen to have the mesh, which has no collision on it. Let's go back to this collision component. It's a projectile type, and it's going to block, it's going to hit world static, dynamic, pawn, physics, bodies, vehicles, destructibles, and enemy meshes and enemy capsules. This is something from another demo. But these are the primary right here. The main thing is pawn. It's going to hit pawn and physics bodies. Pawn and physics bodies. Keep that in mind. Let me get back over here. Go to core, characters, and our character class, viewport, mesh. We're going to go down where that's the physics, collision. See, the object type is pawn, so it's going to hit this. Now we do have capsule components in characters. That's what we're actually moving and jumping and stuff in game. That's what we're controlling when we WASD and so forth. We're moving that. That's what interacts with the game world. It's the collision for the pawn as far as movement is concerned. We use the skeletal mesh, more specifically the physics asset. And where did I go? Scroll up here. We're going to go take a look. So we have the skeleton here, and these are all the bones. So like if I went down in here and we scrolled in on that, we have all the bones, because this is going to come in later. So we got middle finger, and we have all the bones, actual bones, in the hands. But what we hit is these. These are what everybody would call a hit box. The hit boxes. The hit boxes aren't really boxes. They're collision primitives. They're basically capsules, and there are some boxes, but the boxes we generally just put on little simple things like the hand. It's covering the whole hand, and then we have one for the foot. Everything else is just a whole bunch of, so we have pelvis, spine, spine 3, spine 4, spine 5, clavicle left, upper arm left, lower arm left, and hand left. And then we have clavicle right, upper arm, so forth. Then we have neck 1, we have neck 2, and then we have head. But you'll notice that each one of these particular collisions has a physical material applied to it. PM head, and if I open up that physical material, I have a surface type, and that's flesh. We use that to determine what our squib is going to be when we make it, when that projectile hits. That's what fires off that squib, that particle effect for blood. It looks it up and says, okay, the physical material that we hit was this, and so forth. We also use these physical materials for scoring, for damage calculations. We can give this, like if I hit you in the arm, this is the simplest way to do it. If my projectile hits here, it'll report back. Let's go into the client, go in here. So see that collision there? That's the name of it, collision. And we have the on component hit for collision. So when this collision component hits something, this event immediately gets fired by the engine, by the game engine. Not the coder's code, the game engine. It spits out all this data by default. It's built into the core of the game engine. Unity, CryEngine, Source Engine, Godot, you name it. Every game engine has hit events and it has overlap events. So if I went here and did it on begin overlap, and then another one on end overlap. So if I had this set up to do overlap, so right now go to collision, generate overlap events. If I had that enabled, we could get these two to fire. So when I overlapped a certain thing that allowed for overlap here, so if I allowed camera overlap, when my projectile collision overlapped something with the camera collision response, this would fire. It would execute, and it would report back every piece of this data that's here. And when it ended that overlap, so it went through it, they're no longer overlapping each other, the collisions, it would fire this one. That's how we do like trigger boxes and whatnot for certain things. So like if you walked into a pain volume or something, you walked into something that was supposed to give you heat damage, you could use begin and end overlap to apply and stop applying the effect. But collision events on their own, they report back what component got hit. So if I hit a player, where is he at? I can turn this off. You slide him down here. So if I hit the player, the component that would be reported back would be the skeletal mesh. It would be mesh. That's what I hit. That's the component I hit. The other actor, that would actually be the surrogate class. It would be this class name right here. This is the class that it would fire back, and so forth. Other component, it could have been another primitive component that we smacked that and whatnot. Where we get the normal impulse off of that, and we get hit data. This is the main thing that the hit event fires, is this guy. And this is all the information that's contained in that. So we get the physical material from what we hit, and then I can use that in a surface map to pull back that surface, and that's going to end up being flesh. And then that tells other systems, hey, we need to spawn the blood splatter or whatnot. We got the Physmat, but if I wanted to get into more details on what I hit, what bone did I actually hit? Got hit bone and bone name. They're going to pretty much bring the same thing back. So there's a lot of data here. We can use the impact normal for the decals and so forth. Where in the game world did it hit? What was the literal impact point that we hit? So there's a lot of data that the actual collision gives us. So this gives us the actual hit result, whether or not it hit something or what it actually or what it hit, where it hit, and all the other data that we need for that. And then for this particular system, I'm running it back on the projectile hit. So on clients, we do the projectile hit here, and it does a little basic hit detection, little thingy right there. And we're just mainly just doing decal effects. On clients and on sims, we're just doing decal effects. So that's run up out of there. Compile that, and let's go in core characters components, and we need to get the servers. So on a server, we're getting the server hit detection. It's a lot more brutal. See, I can do actual server projectile penetration set up in here, but we're taking the same data, we're getting all that hit data, and we're running it through, checking to make sure that it was a player that can apply damage, and then we're calling a server damage player, which goes through and it takes that hit, gets that physical material, breaks it down into a switch. Okay, which one of these physical materials do we hit? And this is just base damage. If we wanted to get more comprehensive with that, we can get a bone name and use damage curves and so forth to calculate a better one, a more detailed hit. And then from there, it's the sequence. To step 1, calculate base damage. Step 2, we can go through and apply it. And this is server functionality. Only ever runs on a server. Is built into the engines. Most engines have this built in. So It only ever will run on a server. And then this calls an event um, wherever you're applying the damage and calculating. In my instance, I'm doing it in the player state and applying it there. Um, and then since they're still in the server, we're passing an RPC, a packet out to the client and telling its controller to execute the hit marker. So that, in a nutshell, that's it. Um, I think I covered everything, but let's look at real quick. Let's look at the Sims. The Sims projectile, like I was saying before, the client projectiles generally is just the collision. You always need a collision so you can do localized hit detection. And then there's a mesh or a particle effect or something for like a tracer, so you can see that happening, and you can follow it visually going down range. For Sims, simulated proxies, they have a collision, but they have audio as well. So the audio component is attached to the projectile and it moves with it, and that's where we get the flyby sound effect. That's the only way to apply it is we put one on the projectile and we play it when we fire, and it just whizzes down range. I have a little bit more of a more complex setup for this where it determines whether or not it should um, play that sound or not based off how far away it is from the client. So you could have somebody in your game firing a shot, but it's nowhere near you. It doesn't need to be running audio components on it, playing a sound that you'll never hear. So there's logic there to uh, boost performance in that regard. So we got that. We got that. Now with the server is just a collision because it doesn't play audio, it doesn't render graphics or anything. It just needs that. Um, it just needs the collision to fly through, and it's the same setup. The itty bitty little guy, um, 1 centimeter diameter, small guy. So in a nutshell, that's collision and hit detection in the server model. Now to get into Battlefield server model is very similar to this. Let's get back out here. And I don't need any of, no, I don't need any of that. Let's do 2 players again. In Battlefield setup, very similar to what I'm doing here. Let me change so we're both the same color. I'll go to the green guy. You fire a shot, and then you send a message to the server saying, hey, I fired a shot. It doesn't simulate anything on its end. It just does the calculation to where should that shot start. So where's the muzzle position of its copy of you right now at the given point in time in its simulation? That's the start point. And what's our velocity? You know, we got the 790 meters per second. That's how fast that projectile is going to move. When we need to get a forward vector downrange, we're going to calculate that. So it would look at my near zero point 100 meters away. So basically way out there in the distance. And that's where the shot's going to. Let's apply that muzzle velocity to that shot. So it's a little bit of math, not very complicated. And then boom, it would package up those two values in a struct and fire them down to everybody's copy so everybody else gets the shot. Like the guy on the right, we're getting that shot. He's doing its own shot. It would do that. Just like my system does, it would do that, except it's not firing, it's not running a simulation of projectile. In its copy of the game, its simulation, it's not running that projectile. And it's just giving the values for it, storing that information, and passing it off to the Sims. When we get a hit, when I get that blood splatter hit, my client then says, hey server, I hit something. Or it could specifically say, I hit client 2. The server then gets that RPC, and that's the key here. It has to get your new packet saying that you hit. If it doesn't get that hit, you're never going to get the server hit. Never. It's gone. It might try to resend, but typically it's not going to get it, and that's where we end up dying before we get the packets off. So we have packet loss there. So that's their generalized model. Client fires, notifies server it fires, server notifies everybody else that you fired. When you get a hit, you notify the server that you hit. It runs its lag comp and then checks the simulation. Then actually does the simulation of the projectile flying through the simulation and see if it hits. And lag comp, if it doesn't hit, no hit is granted, no damage is applied. If it does, damage is applied. This is using lag comp there. If there's no reason for it to actually simulate every shot like my system is doing. Mine's real time simulation of shots, so there's no lag in getting the data. So when I shoot, I'm sending it, the server's getting it, processing it, doing its own shot, and telling everybody else to do a shot. So we get that real time, boom, and then when hits hit, boom. And that's where hit markers come in. So when the server verifies that you got a hit, validates your hit, that's when you get a server hit marker. So in Battlefield games, blood splatter just means you got local hits. Hit markers mean you got server hits. And if you're not getting server hits followed up by your blood, you have your blood shot, your splatter happen. If you're not getting a server hit marker after that shot for each shot, you're either missed in its simulation, which is possible, or you have packet loss. Not saying that it's a huge thing. It's just like it's just that one particular packet might have dropped off and it's gone, and you have to eventually resend it. But in most cases, you're typically dead before you can actually resend it. So that's it in a nutshell. If you have any questions on that, I mean, it's a broad topic, but we get into some details on things. We can go through it. Oh, there is one thing that I wanted to mention. Tick simulations, frames. On clients, we call it FPS. In the server environment, we call it tick. But devs, we call it on both sides of the fence. They're ticks. We do have ticks in the where's it at? Class settings. Class defaults. Tick. Actor tick. It's tick, and we can go into. Let me go over here on this thing. Event tick. This fires every frame. Every frame. Every class has one, and they fire and they do things. Every frame. It's just a tick. And we have a higher tick rates on clients than the servers. Servers is set up to 60 hertz. It fires one at that rate 60 times a second. We might be running 120 FPS, so we got 120 ticks a second. So we do have that tick, and it's different than the server. But also, what an actual tick is, it's a sequence of processing on the server. Let me hop over into that actor ticking. Right here, right in the Unreal Engine docs, and you can find this on Unity, Godot, CryEngine, Source 2. They have a set game loop that happens, and that's what the tick is. And we generalized in here. Let me see where I want to get down into the examples. So like a lot of the questions are, well, the hitboxes moving on characters, they're not aligned. Player's animated actor would move and animate in TG prephysics. And what that generally means is we move the character component. So I can go back here, and we're going to move this first because that's the movement. That's what we're actually moving in the game world. We move that, then we would snap the mesh and anything that's attached to that mesh. In that same processing loop, it would snap to the new position, and then we'd apply animation to it. So if I was in a running state, we would shift to the next frame or two in the running sequence of the animation. I could show that to you. If interested, just let me know. Um, but everything, including the physical materials on the collisions on the mesh, they're going to snap. Let me just show that to you real quick. But they actually process at the start of the tick. We get all this stuff in the movement handled, and then other things take place in a sequence of the loop prior to actually rendering on screen. So you get your game thread processing and then your render thread processing. So there's no way for your collisions, your hitboxes, so to speak, to lag behind because they are moved at the same time in the tick of the game loop in its particular tick group. Let me go back to that. So we have all these different tick groups. So we got pre-physics, during physics, post-physics, post-update work, etc., and so forth. These always happen in a specific. So everything that's set up to run in pre-physics executes the full game thread of pre-physics. Every actor and component that has to run in pre-physics runs. And then, once all of those are done, during physics can start executing. Once they're all done, post-physics, then post-update work, etc., etc., etc. And then we get to the to the rendering of it, of the particular thing. And even in the game thread render thread setup, the game thread simulation, all this stuff is 2 frames ahead of your rendering. So if I processed, say I'm processing tick 100 simulation, you wouldn't get that until 2 more frames down. You wouldn't get the results of that until 2 more frames of process rendered on your screen. So you'd be the third. That tick 100 simulation wouldn't render until generally tick 102 or tick 103. So yeah, there's that. And I wanted to show you that. Let me go one player, selected viewport, and then I'll pop this in the third, and then we'll do show collision. There we go. See the collision? You see how it's sticking with me? It's moving with me. I'm going to jump and then pause it, punch out, and I don't know why it does that. It just turns off. But what we're going to do is we're going to frame skip. See how the collisions, they snap? They're always where they're supposed to be. And the only reason why we see that little blur is that's render lag. We got quite a bit of render lag there. And that's a per frame simulation. That's what the engine is doing on that simulation. And we see the animation at a frame skip at a time. How it's just slowly moving it. And we interpolate it. But notice all those collisions are staying in place. Anyway, thanks for watching. Any questions you might have on any of this? You want more details on certain aspects, just let me know. I'll be glad to do another video. Appreciate your time.